After studying this unit, you will be able to name haloalkanes and haloarenes according to the IUPAC system of nomenclature from given structures. Describe the reactions involved in the preparation of haloalkanes and haloarenes and understand various reactions that they undergo. Correlate the structures of haloalkanes and haloarenes with various types of reaction. Use stereochemistry as a tool for understanding the reaction mechanism. So this is very important. Use stereochemistry as a tool for understanding the reaction mechanism. Appreciate the applications of organometallic compounds. Highlight the environmental effects of polyhalogen compounds. Haloalkanes and haloarenes. Halogenated compounds persist in the environment due to their resistance to breakdown by soil bacteria. Means why the haloalkanes, or you can say chlorinated compounds or halogen compounds, because it's difficult, because they are not broken down by the soil bacteria, so that's why they retain in the soil or in the water, and when it is they are intaken by the living organisms like plants, animals, human beings, so that will create a problem in the physiological reactions. The replacement of hydrogen atoms in an aliphatic or aromatic hydrocarbon by halogen atoms results in the formation of alkyl halides, haloalkanes and aryl halides, haloarenes respectively. Haloalkanes contains halogen atoms attached to sp3 hybridized carbon atom of an alkyl group, whereas haloarenes contains halogen atoms attached to sp2 hybridized carbon atoms of an aryl group. Many halogen containing organic compounds occur in nature, and some of these are clinically useful. These classes of compounds find wide application in industry as well as in day-to-day life. They are used as solvents for relatively non-polar compounds and as starting materials for synthesis of wide range of organic compounds. Chlorine containing antibiotic chloramphenicol produced by microorganisms is very effective for the treatment of typhoid fever. Our body produces iodine containing hormone thyroxine, the deficiency of which causes a disease called goiter. Synthetic halogen compounds chloroquine is used for the treatment of malaria. Halothane is used as an anesthetic during surgery. Certain fully fluorinated compounds are being considered as potential blood substitutes in surgery. In this unit, you will study the important methods of preparation, physical and chemical properties and uses of halogen compounds. Classification: haloalkanes, haloarenes may be classified as on the basis of number of halogen atoms. These may be classified as mono, di, polyhalogen, tri, tetra, etc. compound depending on whether they contain one, two or more halogen atoms in their structures. Monohalogen C2H5 is X is a monohaloalkane. C2X means it's a dihaloalkane, and then if 3 carbon halogens are attached to each 3 carbon, then it's a trihaloalkane. Monohaloarenes means a 1 halogen attached to benzene ring, dihaloarenes 2 halogen attached to benzene ring, and trihaloarene means 3 halogen attached to the benzene ring. Monohalo compounds may further be classified according to the hybridization of the carbon atoms to which the halogen is bonded, as discussed below. Compounds containing sp3 CX bonds, X is equal to fluorine, chlorine, bromine, iodine. This class includes alkyl halides for haloalkanes. In alkyl halides, a halogen atom is bonded to an alkyl group. They form a homologous series represented by CnX, 2x, 2n plus 1x. They are further classified as primary, secondary, or tertiary according to the nature of the carbon to which the halogen is attached. If halogen is attached to a primary carbon atom in an alkyl halide, An alkyl halide is called primary alkyl halide or primary alkyl halide. Similarly, if halogen is attached to secondary or tertiary carbon atom, the alkyl halide is called secondary alkyl halide or tertiary alkyl halide. So this halogen attached to primary carbon, then this is the halogen attached to the secondary carbon, and this is the halogen attached to tertiary carbon atom. So it's a tertiary haloalkane. Allylic halide, these are compounds in which the halogen atom is bonded to an sp3 hybridized atom adjacent to carbon-carbon double bond. So double bond to an, that is to an allylic carbon. So it's carbon-carbon double bond, then next carbon, and then halogen is attached, that's allylic carbon. Similarly, in the cyclic, so after double bond to the adjacent carbon atom, if an halogen is attached, that is known as the allylic carbon. Well, that is the allylic halide. So benzylic halides, these are the compounds in which the halogen atom is bonded to an sp3 hybridized carbon atom attached to an aromatic ring. So this is the benzylic. So this is the tertiary benzylic. R dash is equal to H, that is the secondary, and if R dash is the methyl, H, that is this is the primary halide. Then compounds containing sp2CH bonds. This class includes the vinylic halides and aryl halides. These the vinylic halides, these are the compounds in which the halogen atom is bonded to sp2 hybridized carbon atom of a carbon-carbon double bond. This is the vinylic halide. Then to the cycloalkene, that is the halogen attached to the carbon which is having the double bond. Aryl halide, these are the compounds in which the halogen atom is directly bonded to sp2 hybridized carbon atom of an aromatic ring. This is the aryl halide.